Let us look at a much more modern application of matrices, that is in artificial intelligence. Now, matrices are one of the most important mathematical tools used in artificial intelligence. They provide an efficient way to store data, represent relationships, and perform the large number of calculations required by AI systems. Now, remember, a computer cannot directly understand images, sounds, or text. These are first converted into numbers. For example, consider a grayscale image consisting of 3 by 3 pixels. Pixels is just a single smallest point on the screen. So 3 by 3 is practically, too small. But let's take it as an example to understand it. So which means a 3 by 3 matrix will contain 9 elements in 3 rows and 3 columns. And these represents the grayscale or the brightness of the pixels. So each number represents the brightness of a pixel, thus the entire image is represented as a matrix. Similarly, information about a person may be stored as a vector. As a small example, we have a vector x in the form of a matrix, which contains the age, height, and weight, not the descriptive terms, but the numerical values. Now, AI systems process such numerical representations using matrix operations. The knowledge learned by an AI model is stored in matrices called weight matrices. Suppose an AI system receives 3 inputs, 25, 170, 65, as a matrix, and uses a weight matrix W is equal to a 2 by 3 matrix. Remember, this is 3 by 1. This is 2 by 3. So the the order of these matrices should match for multiplication. So the AI system computes W times X, weight matrix times the, let's say, data matrix. And we get the result as a matrix which is of 2 by 1 order. So 41.5 and 107. Now, of course, what this basically represents depends on what kind of query it is. Here it is just an example. The resulting vector, remember everything here, each column represents a vector. So the resulting vector contains information extracted from the original data. Every layer of the AI system performs similar matrix multiplications. Now, initially, the entries of the weight matrix are chosen randomly. So this may be initially randomly chosen. When the AI makes mistakes, a learning algorithm modifies the entries of the weight matrix so that future predictions become more accurate. So what happens? We have the initial weight matrix with randomly picked weights or entries. Mistakes or errors, the entries are changed. So we get an updated weight matrix. Again, an updated weight matrix. And that is how the AI system keeps learning. And the objective is to get better and better results. So until satisfactory performance is achieved. Now let's look at an example in a little bit more detail. Now the example is recognizing a face. Suppose an image contains 1,000 numerical features extracted from a face. These features form a vector. So let's say the vector is x equal to 1,000 features. So this is single vector in matrix form containing 1,000 rows. A weight matrix of order 500 by 1000 transforms these 1000 features into 500 new features. We get a higher level set of features. That is because when we multiply the weight matrix with this vector x, what happens? We have a 500 by 1000 and this is 1000 by 1. So the resulting matrix would be 500 by 1. Another matrix transforms 500 features into 100 features. And a final matrix produces the probability that the face belongs to a particular person. Now the sequence of calculations is, we start off with the input data x, we carry out w1 times x, which gives us the result. That resultant again is multiplied by the second weight matrix, then the third weight matrix, and so on. Now, if the AI only learned to recognize one particular photo, it would be useless in practice. The key is that it learns features that are common across many photos of the same person. Now, this is very critical. So, suppose the training set contains hundreds of photos of the same person, looking left and right, smiling, not smiling, different lighting conditions, different backgrounds, different camera distances, different ages. So during training, a loss function compares the prediction with the correct identity of the person in the image and computes an error. A learning algorithm adjusts the entries of the weight matrices to reduce this error. After being exposed to many photographs of the same person, the entries of the weight matrices are adjusted so that the AI emphasizes features that remain relatively stable and ignore features that change. So background may change. So that is irrelevant to recognizing the face. So it will ignore or de-emphasize the background. I'm giving a very simple view of what is happening and how matrices are being used in artificial intelligence. Now, after all the matrix multiplications, the AI may produce a vector of probabilities, indicating the likelihood that the face belongs to the person in the training set. Thus, the AI gradually extracts increasingly meaningful information from the image. Now, where does this enormous training set come from? Modern AI systems require vast collections of images. Many of these images are obtained from publicly available sources on the internet, including websites, image repositories, news archives, and in some cases, social media platforms. The resulting data sets may contain millions or even billions of images showing people under different lighting conditions, backgrounds, poses, and expressions. Just have a look at your own photo library, and you will realize that there is a huge collection of photos. So, in summary, AI stores learned knowledge in weight matrices, and learning consists of adjusting the entries of those matrices. That was a very high level understanding of how matrices are used in artificial intelligence. Anything beyond this, we might have to get into programming aspects. So I want to avoid that. So that was application of matrices. Fourth example. That's it for now. Bye.